There is a small rectangle of white plastic on almost every wall in Britain that no other country bothers to install. A switch sitting directly above the socket that lets you kill the power to a single plug without touching the plug itself. You have flicked it 1,000 times without thinking about it, off before you pull the toaster out, off before you unplug the phone charger overnight. Nobody taught you why, you just learned that this is what a wall socket is supposed to look like. But travel to France, or Germany, or the United States, and the switch is simply not there. You push the plug in, you pull it out, and nothing on the wall asks your permission first. Britain is one of only a handful of countries on Earth that wires its homes this way. This is not a story about a light switch, it is a story about a wartime shortage of copper, a plug designed to survive a bomb, and a safety standard that never let go. This physical distinctiveness begins with a formidable chunk of thermosetting plastic, the British standard 1363 plug. Introduced in 1947, it is a heavy, unapologetic object that dwarfs the sleek, lighter 2-pin plugs common in continental Europe and North America. 3 massive rectangular brass pins protrude from its substantial insulating base. The top pin, the earth, is longer than the other 2, engineered to mechanically slide open safety shutters hidden inside the wall. Inside the plug's body lies a removable cartridge fuse nestled in a small, user-accessible carrier. Red fuses represent a 3-amp limit on low-power devices, while brown fuses indicate a 13-amp maximum for heavy-duty appliances. Individual replacement fuses remain a common staple of local hardware shops across the nation. The final piece of this domestic system is the switched socket itself. Installed in walls and skirting boards since the late 1940s, this matching outlet places an individual on-off switch directly above each receptacle, making the entire assembly feel remarkably robust. In 1942, as bombs fell on British cities, the government began planning the massive reconstruction of its housing stock. The Ministry of Works convened the Electrical Installations Committee, chaired by Lord Reith, to solve a severe resource crisis. Copper, vital for wartime munitions and industrial production, was in extremely short supply. Traditional electrical wiring, known as a radial system, ran individual thick cables from a central fuse board to each separate outlet. Rebuilding millions of homes this way would require vast amounts of heavy copper wire that simply did not exist. The committee's solution was the ring final circuit, a design that fundamentally changed domestic wiring. Instead of separate runs, a single continuous loop of cable departed from the main fuse board, traveled through every socket on an entire floor, and returned to the same starting point. This closed loop meant that electrical current could travel in 2 directions simultaneously to reach any single outlet. By splitting the load, the wiring could be significantly thinner, reducing the total volume of copper needed for a typical house by 30%. This economy made rapid, low-cost housing construction possible during the post-war rebuilding boom. But the design introduced a dangerous vulnerability. A single thin ring circuit was now protected by a heavy 30-amp fuse at the main board, capable of carrying enough current to power multiple high-draw appliances at once. If a lightweight appliance developed a fault on this high-capacity loop, the massive current could easily melt its power cord before the main fuse ever tripped. A typical household ring circuit can safely deliver up to 32 amps of current across the entire loop. But while the heavy house wiring easily handles this massive flow, the thin, flexible cord attached to an individual appliance like a table lamp cannot. If a short circuit occurs in a low-power device, the thin copper inside its power cord will melt and catch fire long before the main 32-amp breaker at the consumer unit ever detects a problem. This is where the plug fuse acts as a targeted protective gate. Sized specifically for the appliance's power draw, a small 3-amp fuse will fail instantly if current surges, protecting a delicate lamp cord. For heavy-duty appliances, a 13-amp fuse provides the necessary threshold. The fuse safeguards the flexible lead itself, leaving the main circuit to be guarded by the distribution board. BEE's 1363 unified this fused plug with its matching shuttered socket, eventually becoming a mandatory standard for all new domestic installations. Within this design, the cartridge fuse and the wall switch perform entirely distinct safety roles. While the fuse prevents overcurrent damage, the switch provides immediate physical isolation, allowing users to cut power directly at the wall. The physical wall switch exists to solve a specific physical hazard: electrical arcing. When a plug is inserted or removed under load, electricity can jump across the tiny gap between the brass pins and the socket contacts. By breaking the live connection before the plug even moves, the integrated switch eliminates this risk. In the late 1940s, this was a pressing concern, as fire investigators blamed older, unswitched round-pin outlets for multiple domestic fires. Rather than reacting to a single disaster, post-war authorities took a cautious, preventive approach to safety. The British Standards Institution codified the switch into the original 1947 BS1363 specification. Once written into national standards, the design took on a life of its own. For 70 years, the entire British building industry has standardized around this single choice. Electricians learn to install them, inspectors expect to see them, and housing developers buy them in bulk. Because manufacturers tool their factories for switched sockets, the unswitched alternatives offer virtually no cost savings. This broad supply chain alignment has created an unbreakable institutional lock-in, turning a post-war safety measure into a permanent national habit. If this story interested you, there is a video right here about what happened to the British High Street. Please subscribe for more. While Britain developed its self-contained plug defense, other nations took different paths. Continental Europe's Schuko system uses 2 round pins and side earth clips. It is completely unfused and unswitched. Instead of placing protection inside each plug, European installations route overcurrent and residual current safeguards back to the central consumer unit. The United States follows a similar philosophy. Its 2-pin and 3-pin NEMA outlets remain permanently live, relying entirely on panel-mounted breakers, ground fault interrupters, and modern arc fault detection. These structural differences represent different distributions of engineering responsibility, not a hierarchy of safety. BS 1363 itself travelled far beyond British shores. Through administrative and commercial networks, the standard became the domestic default in Ireland, Malta, Cyprus, Singapore, and Hong Kong, anchoring a global network of switched, shuttered sockets. Today, modern consumer units feature residual current devices and miniature circuit breakers that cut power in milliseconds during faults. These safety layers reduce the localized wall switch's standalone protective role to mere convenience, yet British wiring regulations and building inspectors still expect BS 1363 switched outlets in every new build. Electricians install them because suppliers stock them, and manufacturers maintain the tooling, locking the design in place. Outfitting a typical 3-bedroom house with 30 switched sockets adds roughly £27 in material costs and £200 in labour over unswitched alternatives. Ultimately, the switch persists because British infrastructure standardised around it, rather than because of any active safety emergency. If this story interested you, there is a video right here about what happened to the British High Street. Please subscribe for more. Today, the British switched socket stands as a monument to wartime resilience. It proves how fleeting crises leave permanent marks on our daily landscape. Long after the copper shortage ended, the habit remains frozen on the wall, a physical anchor to a forgotten emergency.